Hi. So today we will do some questions on potentiometer wire. I have selected 5 questions. So let us start doing with question number 1. Here I have question number 1. You have a long potentiometer wire of length AB is having a constant potential gradient. So let the constant potential gradient be K. Okay. Constant potential gradient along its length, the null points for the two primary cells of EMF E1 and E2 connected in the manner shown. Okay. Firstly, they are connected in opposite polarity. E1 and E2 have their positives along other side, and secondly, they are connected in the same polarity because both are having their positive terminals along the same side, and they have their different balance point in these connections. So firstly you have to find E1 upon E2, and then you have to find position of null point for the cell, only cell E1. So two questions are there. Question 1, E1 upon E2 is equal to what? Question 2, balancing length for E1. Is equal to what? So let me start formulating the equations. Since we know that E is proportional to L, the working principle for potentiometer wire E is equal to KL, where K is your potential gradient. Okay, K is your potential gradient. Now for case 1, first connection. So here you have net E, that is equal to E1 minus E2. Both are connected in opposite sense. So you have to do subtract E2 from E1. It is equal to K into, and balancing length is 120 centimeter. So this is first equation. Now second connection. And now they are connected in the same sense. So let me add the two EMFs, and this is equal to K into, and this has come 30 centimeter, 300 centimeter. Okay. So on adding the two, adding the two, you can see that E is cancelled. 2E1 is equal to K into 420. Therefore, E1 is equal to K into 210. It implies that E1 upon 210 is equal to K. It implies that K is equal to E1 upon L1. Therefore, balancing length for E1, this is your answer of question number 2 only, is equal to 210 centimeter. Now second question, what is ratio of E1 upon E2? So I have obtained E1. Similarly, on subtracting the two equations, now on subtracting, the two equations. So let me write again the two equations. E1 minus A2 is equal to K into 120, and the second one is E1 plus E2 is equal to K into 300. So when you subtract, now you will see that E1 is cancelled this time, and you will get minus 2E2 is equal to minus K into 180. So cancel minus from two sides. Therefore, E2 comes equal to K into 90. Now from A and B, dividing A by B, you will obtain that E1 upon E2 is equal to K into, this was your K into 210 upon K into 90. So the answer is 7 upon 3. This is answer of question number 1. So now next question. Let me select question 2. Okay, this question. Next question number 3. In this given circuit diagram below, AB is the uniform wire of resistance 15 ohm and length 1 meter. It is connected to a series arrangement of cell E1, EMF 2 volt and negligible internal resistance and resistor R. Terminal A is also connected to an electrochemical cell E2 of EMF 75 millivolt and a galvanometer G. Okay. In this setup, a balancing point is obtained 30 cm. Mark from A, starting from A. Calculate the resistance of R. This one. Second, if E2 were to have an EMF 300 millivolt, where will you expect the balancing point? So these are the two questions. Now, the working steps will be to find firstly the current in this arm, because in first circuit, if the current obtained is I, the same current will be there for second circuit. So let me find current flowing in AB arm. I must be equal to EMF upon total resistance in series. So R plus R of AB, and this is equal to E1 is given 2 volt upon R we have to find RAB is 15 ohm. Now this is the current. The same current will be flowing in second circuit too. along this part. So I have obtained current. Now we know that since in circuit 2 we know that V is equal to, from Ohm's law, V is equal to IR. I we obtained. V is given. We have 75 millivolt. V is given 75. Okay. V is given 75 millivolt. I we obtain 2 upon R plus 15 into R. R of this length. R of length 30 centimeter. So resistance will be proportional to length. So in this way you can find value of R. Let me obtain value of R. So for proportionality, ratio is same. R30. We should write here R of which length? So here we will be finding value of R, and you can see that R will be proportional to length, and for proportionality ratio will be same. So R1 must be equal to L1 upon total length into total resistance by this equation. So here R1 comes equal to 4.5. RL comes equal to 4.5. Now let me simplify the equation. 75 into 10 power minus 3 into R plus 15 is equal to 9, and therefore R plus 15 is equal to 9 upon 75 into 10 power 3. Okay. So 25, let me cancel it by 25, and this comes equal to 120. Therefore R is equal to 105 ohm. So I obtained R. Now second question is, what will be the balancing length if cell E2 is replaced by one another cell with EMF 300 millivolt? So part 2, since we know that E1 upon L1 is equal to E2 upon L2. Therefore, the first cell was having EMF 75 millivolt upon, and its length was 30. It is equal to, if you replace it with a cell with EMF 300 millivolt, and you have to find L2 only. So cancel these millivolts from the two sides. Therefore L2 comes equal to 300 into 30 upon 75. So 25, 3 times it will go 75, and this is your 3 into 4. So L2 comes equal to 120 centimeter. Next question. The length of a potentiometer wire is 5 meter, is connected to a battery of constant EMF. EMF is not given, length is given 5 meter. This total length is 5 meter, EMF is not given. For a given Leclanche cell, the position of zero galvanometer deflection. You have a lake launcher cell, and zero galvanometer deflection is 100 centimeter length. Okay. Now the condition is, if the length of potentiometer wire be made 8 meter instead of 5 meter. It was initially 5 meter, now it is made 8 meter. So calculate the length of wire for zero deflection. Now what will be length of zero deflection? So let us consider the two cases and potential gradients. How potential gradients are related to length of potentiometer wire. So potential gradient, we know that it is potential difference per unit length. If length is increased, that is in second case, denominator is increased, and so potential gradient decrease. Potential gradient decrease. Now here your EMF is constant. EMF is constant, the same E, and potential gradient means potential drop per unit length decreases in second case. Now for the same length, smaller potential difference drop will be there. So you will have to take a large length. Here you have potential drop, suppose some potential drop, but here potential drop for the same length is small potential drop because potential gradient is small. So for balancing the same EMF, you will have to take large length. Smaller potential gradient, larger length, larger balancing length. How they are related? They are inversely proportional. Small potential gradient, large length. So the potential gradient and balancing length are inversely proportional. Therefore, potential gradient K into L1 is equal to K into L. K1 L1 is equal to K2 L2. So what is potential gradient in first case? This is potential, same potential. Let me take it small e, okay. Small e, same potential per unit. Previously the length was 5 meter. You can convert in the same unit, or even you cannot convert in the same unit because from the two sides meter will be cancelled. So let me leave it into balancing length was 100 centimeter is equal to E upon, now this is your 8 and L2. L2 you have to find. E is cancelled. It implies that L2 is equal to 8 upon 5 into 100. So this is equal to 167. Question 5. AB is 1 meter long uniform wire of 10 ohm resistance. Okay. 10 ohm resistance. Other data are shown in figure itself. Calculate potential gradient along AB. You have to find potential gradient. And second question, balancing length AO when galvanometer shows no deflection. So you have two questions. So for potential gradient, we will be using main circuit, upper circuit, which is auxiliary circuit containing 2 volt battery. And we know that I, and what is the working steps for potential gradient, which is potential per unit length. Length is given. So we will calculate first of all potential. and potential V is equal to IR. So R is given, for AB R is given, we are going to calculate I is equal to V upon R. V is given 2 volt, and in this circuit total R is which is in series 15 ohm plus this 10 ohm along AB, and this is equal to 2 upon 25 ampere. So our aim is to find potential difference of length AB. From Ohm's law, it is equal to IAB into RAB, and this comes equal to 4 upon 5 volt. Now our first question was to find potential gradient. Potential gradient is equal to potential per unit length. So potential is 4.5 we obtained, divided by length is 1 meter or 100 centimeter. So this is equal to volt per centimeter. We obtained potential gradient. Now for second question, we need to know balancing length. And we know that working formula is potential is equal to potential gradient into length. We need to know, let me change color, we need to know balancing length, and we already have obtained potential gradient. We have potential gradient. So we need two things, balancing length, and for that we need terminal potential difference. What is terminal potential difference? All these are in parallel. This point will have same potential as this point, and this point will have same potential along this arm, along this arm. So we will find potential along 0.3 ohm resistance. When no current flows through galvanometer, the resistors are in series. So in circuit 2, let me mention circuit 2. This is your circuit 2. Total resistance you can see 1.2 plus 0.3. When no galvanometer deflection, the circuit is delete. The resistances are in series. Therefore, R is equal to, in this circuit, 1.2 plus 0.3. Okay. 1.2, 1.5. So I obtained resistance. Now current I of second circuit is equal to V upon R, and this is equal to, V is 1.5 volt upon R. I have obtained 1.5, 1 ampere. Okay, 1 ampere current is flowing. Therefore, PD across 0.3 ohm resistor is equal to IR, and this is equal to 1 into, from here 1 into 0.3 is equal to 0.3. So potential difference is 0.3 volt for second case. V is equal to 0.3 volt. Now from equation 1, point 3 is equal to, and K I have obtained 1 by 125 into L. L will come in centimeter only, because in potential gradient I have taken length in centimeter. Therefore, L is equal to 37.5 centimeter.